Kami amaiko mfe wenu vavanankani vakose vakuchipata valavutukananikani amananikani matraps valatoloka valishivo vakuchipata watani nishimala that's okay mara tusanga then but mara tutashani vakoso avo
ofisi washukiri sana ni muno haya bila
oh yes sana
Like when you at the market or Canada, 19 hours, they start taking off.
mkwae
Because it,
19
hours, they even start taking, what are you doing?
nachawa vana vamatambo yati avalemonka vavakumia na vakuchipata vantu valetoloke vya kutoloka toloka yeah they've caused a lot of distractions yeah. Wafya
Last week I had to keep eating the wall. So that they don't come because they were moving around.
It's terrible. Ndo se defi.
Wow.
Thank you. Would be okay. Sure. Good afternoon, colleagues. Good afternoon. Afternoon, colleagues, once again. Yeah, loud and clear. Yeah, so today, thanks a lot. Today we're going to focus our attention on low power communication technologies. In addition, what sometimes is known as the LoRa technology. So that's what you're going to look at. So just do this. Okay. Low power communication technology basically refers to wireless communication methods that are designed to operate with minimum energy consumption. Okay, so here we are basically focusing our attention on devices that do not use much power. Okay, devices that do not use much power, so they consume minimal energy. These are the ones we are looking at, but they're low power communication technologies. Okay, they are wireless communication methods. Okay, and from the design, they are designed in a way that they can only make use of low energy. So now, these technologies are often used in devices that require long battery life or energy efficiency, such as wearable devices or Internet of Things. Okay, where we talk about the sensors and other embedded systems. So we are not like making use of them in each and every device, but there are certain devices that are applicable to this kind of technology. Come in. Okay. Okay.
different advice regarding the fourth course for us who are in second
Are you able to get
semester
into?
taking computer science. Um, some people are saying that they would have to put IT project management, even though that's not in our
You are doing
curriculum. Science.
computer science. You are supposed to computer science. There's data communication and computer networks, advanced object oriented. That's if you did the object oriented programming. Then there's computer organization and architecture. Then web application development.
Yes, so the problem is on the advanced object oriented
Okay. So if that is not there, you can pick any of the courses in third year.
Is it possible to take three courses this semester?
No, we don't allow it. You can pick either mobile application development or artificial intelligence and decision support, software design and architecture, or free and open source software. Yeah, any of those, but you can't be allowed to pick three. When you pick three, I check, I'll reject your registration. Yes, because I have to approve it. When you register, I have to approve. So anything below the required a number, we are not approving, just reject.
Is it possible to take five?
If you did well, you can take five.
Did well last semester.
Mm.
Okay.
Yeah, you can be allowed to take five. Mm. You've done the registration, you registered?
Yes.
Okay. So what did you register as the fourth course? Yeah, that's it. Mm. Myself, so no need to worry. Yeah, it's fine. No problem. Okay, colleagues. Okay, colleagues, sorry about that. Um, so I was saying, no, no. Yeah. So what I was saying is that low power communication technologies are basically wireless communication methods that are designed to operate with the minimal energy consumptions. Okay, and these are designed from the manufacturer's point of view, in a sense that uh, they should be able to require long battery life. Okay, so that they're able to be energy efficiency. And yeah, we have good examples which include wearable devices, okay, then internet of things, sensors. We talk about sensors and other embedded devices. These are the specific devices that we can point at to say these have been given that priority to have at least long battery life, so that they're able to be an energy efficient. So the goal is basically to enable the wireless communication while conserving energy to prolong the device operation lifespan. So as much as these devices are being put there, actually the whole idea is that we want to ensure that this wireless communication is ongoing. Okay, is ongoing, so that the uh, the energy is also conserved. Okay, you don't whereby you are communicating and within a short time you find that you've run out of the battery is low and so forth. So that will affect the transfer of data between the devices and so forth. That is why from inception, these devices are made in a way that at least they have long uh, life batteries that are energy efficient. Okay, so wireless communication is ubiquitous. Okay, when we say ubiquitous, what do we mean? When we say it's ubiquitous, what do we mean? Okay, Mr. Maxwell, what do we mean when we say it's ubiquitous? It's what? Okay. Yeah, and also absolutely could also look at it to say it comes out in so many forms. Okay, so now these are some of the forms that we have. We have what we call the Bluetooth, Wi-Fi, cellular. Okay, the Bluetooth. We also have what we call device to device, or what we call Bluetooth low energy. Okay, where you are just transferring information from one device to the other. Okay, like we've been able to transfer files from one phone to the other. Then we also have what we call device structure. Okay, device to infrastructure. So I can put it like this, where we talk about long-term evolution. Okay, it's a technology actually that is used on wireless communication. Okay, we have device to device, then device to infrastructure, then you have Bluetooth low energy, which is the most popular wireless protocol that we have. Okay, so these are very, very popular aspects that we talk about. So this is basically just the preamble. This is just the preamble. Of course, now the outline of what we are looking at is that we look at the radio, then we try and understand how the radio works. Okay, what is the radio and how it works? Then we'll also look at the fundamental characteristics by focusing on the design trade-off of these wireless communication devices. Okay, fundamental characteristics of these wireless communication devices. Then we also look at the common radio standard protocol for indoor applications. Okay, what are the protocols for indoor applications? Then where characteristics falls under. Okay, what are some of the characteristics? Then you also look at the emerging radio standard protocols for outdoor Internet of Things applications. Okay, so what is it, or what type of radio standard protocols do we need for outdoor Internet applications? Okay, okay. So then you also look at why the design requirement of IoT radio is different. Okay, so this is what we are going to look at. Okay, with that said, let's move straight to here. So what are radios? If you look at that, what are radios? We just hear about radios and so on, but you need to understand what these are. So basically, a radio is a device that enables wireless transmission of signal. Okay, a radio is basically a device that enables you or anyone else to transmit um, the signals wirelessly. Remember, we have the point-to-point connection where we have connected the devices that must be connected in order for the transfer of information to take place. But now, when you talk about the radio, we are saying it's a device that enables wireless transmission of signal. So the signal is being transmitted wirelessly. Okay. Now, how does this take place? It is transmitted wirelessly through the use of electromagnetic wave, where we have the transmitter encodes the signal and the receiver decodes it. So, in terms of transmission, we are saying for radios, we have the data being transmitted using electromagnetic waves. Okay, once this is done, when this is being done like that, the transmitter has to encode the signal in a form that is transmittable via the electromagnetic waves. And when it reaches the receiver has to the receiver has to decode the receiver has to decode this signal so that it's able to make sense out of that communicated information. Coming.
Good afternoon.
Afternoon, thank you. Please take a seat. Sure.
My name is Stacy Miller.
Okay.
I'm here to drop off a withdrawal form on behalf of Kamwaching. I visited the admissions office earlier in regards with the same, and they told me that I had to drop off a form here for your approval, then I submit it to the finance office so that they welcome it.
Why is he withdrawing?
After his father's passing, he was tasked with a lot of responsibilities at home, seeing as he's the only one in the family.
He's the only one.
Yeah.
So where does the issue of gender comes in?
I don't know, but traditionally,
Forget about tradition. Now you guys believe now that uh, a man is still a man.
unfortunately, that belief is still. Oh yes, he was tasked with all those responsibilities, taking care of the family, and then he also had to juggle that with his work.
Okay. What is it? Okay. Okay, so sorry, I'm in class. Okay, so we're saying uh, the radios. Okay, we're saying it's basically a device that enables wireless transmission of signals. Now, these are electronically transmitted using electromagnetic wave. And once the signal is being transmitted, what happens is that it is encoded from one end and then decoded from the other end. Now, how radio works in terms of transmitting, there's an aspect of modulation. Okay, there's an aspect of modulation. This process of modulation convert digital bit to an analog signal. Okay, so these digital bits actually they are transmitted in a form of zeros and ones, and of course, depending on the media that is being used, these have to be converted into an analog, and then the the encoded bit, okay, will have what we call changes in what we call the carrier frequency as it travels or traverses across the transmission media. Now, this carrier frequency causes a lot of changes in terms of the frequency of the signal, the amplitude, as well as the phase. Okay, so this is very important in the way this is done, because usually the signal uses high frequency, okay, as a carrier signal. Okay, for the signal to be transmitted, it needs to have what we call the higher frequency. Okay, so now the higher frequency is able now to help us with the transmission of the message within the signal that can be physically transmitted. So a low frequency message signal, okay, like the one at the top, which is may be carried by what we call the AM or frequency modulation. Okay, AM is basically for amplitude modulation, and then you have frequency modulation wave. So depending on the message that is being transmitted. Okay. So multiple low pass signal transmitted at the same time through separate baseband or carrier frequencies. All these are there to ensure that the data is transmitted. So what you are saying is that the radio, the way it works in terms of transmission, the data can either be transmitted using amplitude modulation or frequency modulation. But in either case, what happens is that the bits, okay, the digital bits are basically converted to analog, and they're able to be transmitted into what we are calling the carrier frequency. Okay, and in this carrier frequency, which comes in form of a wave, okay, then we can be able to transmit either using the AM amplitude modulation or frequency modulation. You think like for you, Mr. Maxwell, you are an engineer, you understand this, you already deal with this already. Yeah. It, sure, sure. Yeah, so now, thank you. Yeah, sure. Yeah, so I saying example of modulating digital data onto an analog signal. We have this digital where data is represented using zeros and ones. Okay, we have one there, then zero, one, zero, one, and so forth. This is data. Okay, then you have the carrier. the carrier frequency. This one is part of the amplitude modulation, and then you have modulated the signal that is produced at the end of the day. So this is basically to do with transmitting the signal. Now on the receiving end, what happens is that um, we have what you call the envelope detection, which detect changes in carrier frequency. Okay, so this detect changes in carrier frequency. So the complex, this one requires what we call synchronization, so that there's that aspect of uh, filtering certain signals that are not some kind of noise, so to say, to ensure that only the original signal is transmitted. Okay, so the signal must be demodulated, okay, on the receiver, and so that only the original signal that was transmitted is able uh, to be received. So here we are talking about the AM radio example. So we have the antenna. Okay, this antenna picks up a modulated radio waves. That's the antenna. Okay, then we have from the antenna there we have the filter, or the tuner rather, that filters out specific frequencies. You've seen even when you are filtering, you are trying to get a channel on a particular radio station. Even in your car, you find that you need to use a tuner. Okay, so that you are able to tune to a specific frequency. Okay, which will come out clear without any distortion. Okay, so now after the tuner filters out specific frequency ranges, the amplitude variation detected with the modulation also comes in. Okay, where the amplifier now strengthened the clipped signal and send it through to the speaker. Okay, so this is what happens at the frequency, the receiving end. We have the antenna. Remember, we're talking about transmitting wirelessly. Okay, transmitting wirelessly. We have the antenna that picks up a modulated radio wave. Okay, then from the antenna, we have the tuner, where you tune to get the correct specific frequency range. Okay, then after that, you have the detector, which is the amplitude variation, which able now to detect the variation in terms of uh, amplitude. Then, in addition to that, we have now the amplifier that is there now to strengthen the signal, so that now it sends it out to the speaker and you're able to listen on a clear signal, clear sounds. Radio characteristics. Radio characteristics. Why so many protocols for indoor and outdoor applications? Why is it that we have so many protocols for indoor and outdoors application? Okay, the answer to that is that all radios have to make trade-off, meaning there are certain sacrifices that have uh, to be made. Okay, from all the radios, because they are there to transmit the data wirelessly. Okay, trade-off has to be made. So we do have what we call the short versus the long distance. So considerations have to be made. Okay, considerations have to be made depending on the circumstance and depending on the situation. Where if short, we are trying to transmit over a short distance compared to a long distance. So that's the characteristics. Okay, that's the characteristics. Then high versus low power energy. Okay, if you are transmitting using a device that uses more power, okay, and then compared to the devices that uses low power, then certain considerations must be made. Okay, what we are calling the trade-off. Then high versus low speed. In terms of speed, again, certain trade-off must be made. Then large versus small number of devices, then certain considerations must be made. Then device to device to infrastructure, okay, maybe like from a device to an infrastructure or network, or indoor versus outdoor. All these are some of the characteristics, radio characteristics that you must consider. So here we are saying, why so many protocols for indoor and outdoor application? Why is it that we have so many rules or protocols that we want to consider? So here what we are saying is that the reason why we have all these protocols is that we have uh, um, all radios have to make certain decisions. Okay, they have to make certain decisions depending on the situation or depending on the circumstances. Okay, these circumstances can be when transmitting over a short compared to long distances, when transmitting over a high compared to low power energy, when transmitting over high versus low speed, and compared to large versus small number of devices, transmitting devices to device or device to infrastructure, or indoor versus outdoor. And these are the common radio protocols that we have. Radio for indoors application, radios for indoors application, their design requirements include the following. If you want to design radios for indoor application within, or in short, if you are to consider the networking concept, you could say maybe under um, local area networks. So we talk about the design requirement. This must be short range, okay, short range, but you expect high data rate in terms of transmission, and also small number of devices. Okay, short range, high data transmission, high data rate, and small number of devices. Now, compared to design requirement for radio for outdoor IoT applications, for outdoor IoT application, the design requirement is that you need long range, not short range. Then the data rate, in this case, we are talking about low data rate, okay, low data rate, and the large number of devices. In this case, we have small number of devices and low energy consumption. Low energy consumption. So these do not require uh, for high level energy consumption, but the low level energy consumption. Common protocols for radio for indoor application. We have the Bluetooth or low energy. Then you have the Zigbee technology. We have the ANT as well as the Wi-Fi. So these are the common protocols that you can use for um, indoor applications. These are the common protocol you could use for indoors. Then for common for outdoor application, you have what we call the GSM, GPRS, as well as the LTE. Okay, so these are the courses. Sorry, these are the protocols that you can find for these outdoor applications. Then we have also emerging protocols. We have Sigfox, LoRa, lower range network. Then narrowband, LTE, and then we also have what we call backscatter. So these are emerging, which are still coming up for use in the IoT, for long range IoT application. So in short, we are saying these are common radio protocols. They are those that are used for um, indoor applications. We have the design requirement, and we also have the common protocols applicable to that. And then for those that are designed for outdoor IoT application, we have equally the design requirements as well as the common protocols and the emerging protocols. We also have the emerging protocols. Bluetooth. Let's look at Bluetooth. Okay, want to look at some of the protocols. Now let's look at Bluetooth. They fall under the radio band of between 2.4 to 2.48 gigahertz. Okay, the average to 1 megabit per second for up to 3 megabits per second. That is Bluetooth. And mostly Bluetooth support point-to-point and point-to-multi-point communication. Okay, they support point-to-point as well as point-to-multi-point communication. So again, uh, Bluetooth create personal area network, or what you call the PAN or PConnect. Okay, they're able to connect up to 8 devices simultaneously. Okay, with Bluetooth, you can be able to connect up to 8 devices simultaneously. And in terms of minimum interference between devices, so devices alter frequency arbitrarily after a packet exchange. So up to 1600 times per second frequency mapping. And 3 classes of Bluetooth transmit power. We have class 1, class 2, as well as class 3. For class 1, the maximum power transmission, we are talking about 100 megawatt or 20 dBm. This operate the range of up to 100 meters. Then you have 2.4 megawatt, which goes for up to 10 meters. And then you have 3 megawatts, class 3, which goes up to 1 megawatts, transmits up to 1 meter. That's the Bluetooth. Frequency hopping, communication was invented by actress Hedy Lamarr, okay, of the United States. So she invented what we call frequency hopping. So this invention relates broadly to secret communication systems involving the use of carrier wave of different frequencies and is especially useful in the remote control of uh, digital craft and so on. So frequency swapping is more like you are trying to hope for the next frequency that you can use to transmit data, the nearest available frequency. So which is applicable in in Bluetooth technology. So Bluetooth application, wireless communication between devices. You use Bluetooth for wireless communication between devices. We talk about mobile phones, laptops, cameras, gaming controllers, computer peripherals, and so on. So short range, short range sensor transmission. Okay, you can use this to transmit information between sensors that are within the proximity, okay, in a short range. They share multimedia. You can share multimedia such as pictures, videos, and music through Bluetooth. Okay. Then ADDP, Advanced Audio Distribution Profile. Good afternoon. Fine. Okay. Okay. Okay, what do you have? Okay. Okay. Even you, it's the same. Okay. Very known. For computer studies direct, you go straight into third year. Yeah, so it means you are exempted uh, year one and two. Mhm. So for in your case, you said it's computer studies, computer science. That's what you did as well. Okay. Let me see the course content. Okay, for you, you get affected slightly because of this psychology, this and that. Yeah, yeah. So, why can't you come with it? Try to do it at once. For him, it's straightforward. Yeah, because just like for this, we'll go straight into you start from here. So automatically, this you are exempted because you are the diploma. So I think for you when you come with that, maybe you can also look at it and guide accordingly. Mm, yeah. Please, you find me. You can maybe even just comment or send a message. But, yeah, sure. All right, thank you so much. Mhm. Mm. You selected the wrong course.
Yes.
What's the student ID?
2024
2024
01
01
92.
982.
It says 153 and open source systems, but it's showing IT project management.
Oh, okay. Let me just- Okay, it's changed. Or for him, or for you, what you need to do is let me see those pages. Let me see that.
So the classes
Those classes are closed, Barrister. Okay. So for you, what you need to do is you copy all these course codes plus courses, the course names. You copy them here. Of course, you fill in your details here. Then you bring a sign and then you take it to the admissions office. And that will be the same even with you. Yeah, now for you, we may exempt you of some courses and then tomorrow we find that yes, better they're done at the same time, yeah, to avoid back and forth. Yeah, so what you could do is this, that, you write the course codes, then the course names, then I'll approve and sign against, yeah, then you take that side.
so from what class in the last year I should put them down.
Absolutely. But of course, you need to attach your,
This one is the certificate.
yes,
Thank you very much.
it's a diploma, isn't it?
Yes.
Yeah, sure. All right, sirs. Thank you so much. Must talk. So we're talking about Bluetooth applications. We said it's being applied in wireless communication between devices for short range sensor transmission, share multimedia, pictures, videos, music, and so on, and in advanced audio distribution profile, especially when you have to stream audio wirelessly. Okay. Then we have what we call Bluetooth low energy. Of course, from 2001 to 2006, we had the Nokia phone, which, okay, that was Nokia. Then the question is, how do we design a radio that can transmit short bursts of data for months or years only, being powered by a coin or a cell battery? Okay, remember we are looking at, we're trying to look at low energy devices that can transmit data for a long time, but of course using low energy um, batteries and so forth. So now we have this question to say, how do we design a radio that can transmit a short burst of data for months or years, only being powered by a coin or cell battery? Now, the answer to that is that you need to keep the radio asleep, in a sleep mode most of the time. But is that really what we want? Okay. Yeah, that's not really what we want. Okay. As a result, what you are saying, there's need of us achieving the following. need to advertise on only one of the three channels. Of course, you will be there are certain channels where you need to advertise so that at least the other areas of the radio is kept inactive. Then you can transmit quickly at 1 megabit per second, come up with a mode of faster transmission. Then you can make the minimum time to send data only 3 microseconds. You make that as your minimum time for transmitting data so that you don't spend time, because by so doing you use much energy. Then you can make a very predictable time when the device accepts connection. It shouldn't be always that the connection should be there, but you have to come up with a strategy to ensure that the device can only accept connection during certain periods. Then you limit the maximum transmission power to 10 megawatts. However, don't sacrifice the security aspect. So as much as you try to implement all this, you don't need to sacrifice the security. So now, what trade-offs were made in terms of Bluetooth technology? So the protocol is designed for transmitting tiny data. Come in, come in. Yes, no.
Sorry for interrupting. Let me just take one.
All right.
Just for the Tenjo.
Thank you.
Just on the this course I was taking last semester.
All right, on both.
Yeah, on both of the HIV part.
Okay. And I was also planning to bring this letter. Hello? Good afternoon, thank you. Okay.
Registered for courses there. They are saying that they need a promotion and they find out how to respond to their program.
Before the end of today.
Now,
Okay. Thanks a lot. Sir.
can we do it? Get
Oh, great.
all right.
You're welcome. Thank you. Good day to you too. Yeah. Teaching from here, dog. A lot of disturbance.
Okay. Today is what?
Today's 7
07
08 224.
So just sign here, not so.
Sure, sir.
Okay.
Thank you so much. Pardon? Yes, these rats. I think we just need the endo seed. Otherwise, it's. Really? That's a nice one. Eh,
So I'm opening my lock, I find it drops, a lot of drops on the top.
it's terrible.
Next to it, the biscuit is also. Okay. So I didn't know that this was here.
That's interesting.
They will laugh at that.
Ah. Okay, so what you are saying is we had the protocol is designed for transmitting tiny data, and we have 4 operations that were made in terms of Bluetooth technology. We have the read, the write, the notify, and the indicate. Read, write, notify, and indicate. So the maximum of 20 bytes of data per packet were actually being transmitted. Hello? Afternoon. Sure. Currently, I think the number should be on the portal, on the website. Which courses are you taking? Uh-huh. Uh, Strategic management. This is the one text. It's showing what's the name of the lecturer? Jerry. Is it Dr. Jerry? Okay, let me text you his number. Mm. Come here. Okay, let me give you Dr. Jerry's class. But normally the links are posted on your portal. Come here. I'll send you Dr. Jerry's. All right, thank you. Please take a seat.
Thank you. We can't see Mrs. Muiza.
Okay.
She's not around. We'll talk to you.
Okay, just a moment. Okay.
You already got the results?
Yes, okay.
Yes. We talked about the courses for the new semester L4.
L4, you're supposed to say
Mrs. Muiza.
Mr. Mweza or Mr. What's his name?
We saw Mr. Muiza. He told us to come to Mrs. Muiza here.
Okay.
And Mrs. Muiza is not around. We'll
No,
just
she's
see-
gone for a meeting, but she's around.
Okay, so
That's NCC.
NCC.
No, NCC is not under my jurisdiction. Yeah, I could either see Mr. Check if Mr. Money is there.
Okay.
Yeah, if he's not there, then you just have to wait for Mrs. Moise. She
Mrs.
should be done anytime soon.
Okay, thank you, sir.
Most welcome. Okay, so I was saying for this, the trade-off were made for Bluetooth, where we are saying the protocol was designed now for transmitting just tiny data, okay? And the four operations were derived, which included the read, write, notify, and indicate. The maximum of 20 bytes of data per packet were allowed to be transmitted. Okay. So here again, we could see it from the diagram here. We have first, you need to advertise. You advertise, then the connection is established. Then once the connection is established, you have the aspect of scanning of the device that needs to be used for transmission, and then the connection is then made. Okay, once this is done, then the data is able to be transmitted. Then the other technology we have is what we call IEEE 802.15.4. So this standard defines the communication at level 2 in the OSI, or Open System Interconnect model. Okay. So this is another technology that is used for transmitting of data. So its main purpose is to let the communication between two devices, okay? Is to let the communication between two devices, in a sense that it was created by the IEEE, an entity whose main task is to set standards so that the technological development can count with a common platform of rules to be set. Okay. In what's more and Squid-B devices, this protocol set is basically set to use what we call the XB802.15.4 of original equipment machine DJ module. Okay, so this is just another technology that is used for data transmission, specifically on the low energy consuming devices. Then you have Zigbee technology. Zigbee is a personal area network task group with a low rate task group 4. Okay, so this is another aspect. It is basically a technology of home networking, okay, for creating network for homes. Zigbee is a technological standard created for controlling and sensing the network. Okay, it's used for controlling and sensing the network. As we know that Zigbee is the personal area network of task group 4, so it is based on it's based on IEEE 802. Okay, 802. Okay. Just, you're going that side. Yeah. Kumuleta kapatri. Or kimontoje kuri wa register. Register is Mr. Mukule. Tabapata secretary should is the active. Okay, I'm going to check the office. Oh, it's the for rebate. Thank you so much. So as we know that the Zigbee is the personal area network of task group 4. Thank you. All right. But because when you leave it here, hey, what? Yeah. So Zigbee is a personal area network of task group 4. So it is based on IEEE 802.15.4 and is created by Zigbee Alliance. Okay, so it was built on top of 802.14.15.4. Okay, so the radio bands for Zigbee is 868 megahertz in Europe. Then you also have 915 megahertz in USA and Australia, and 2.4 gigahertz elsewhere in the world. That's the radio band. The low data rate for ZigBee stands at 250 kilobit per second. Low power up to 100 days. Okay. So they transmit over longer distances through what we call the mesh network. So, of course, through ZigBee, you can be able to transmit data over long distances. Okay, in what is known as a mesh network, so that there's no interruption in case one device fails. Okay, so we have ZigBee profiles, network application layer, data link controller, IEEE 802.15.4.4, and then we have all that to show that this is part of the layer of ZigBee connection. Then why ZigBee? Why should we go for this kind of connection, ZigBee? We are saying ZigBee is basically low power, cost, and the size. It is basically a straightforward configuration. It has a straightforward configurations, and good and support documentations. Okay, mesh networking, such that once one connection fails, you can not really experience the breakdown in connection. Lend itself well to many different applications, and very low wake up times, where we talk about 3 milliseconds and so on. So these are the reasons why transmission through ZigBee proves to be quite important. Okay, so this is basically a diagram to show that uh, it may compete with or with Wi-Fi band, for band, actually only for usable band in Wi-Fi intensive scenarios. And it uses a mesh network, which actually can say consists of series of nodes, and these nodes are interconnected in a sense that each node must acquire and transmit its own data, as well as it acts as a relay for other nodes to propagate the data. That's the kind of connections that this one has. So ZigBee device often form what we call mesh network. Example, we have the wireless light switching, music school practice room, and so on and so forth. Okay, so that's about it. A mesh network, where we have in blue or green we have the coordinator, then the blue one is the router, and red end devices. Mesh networking allow devices to communicate to multiple other devices on the network, and multiple paths. It provides multiple paths to the destination, and this gives us a greater flexibility. In case one device fails, that will not have a direct impact on another device. Okay, so it allows the overall network to grow to a larger physical size than possible with point-to-point connections. Mesh characteristics, it has one characteristics of self-forming, where we are saying ZigBee devices can establish communication pathways when new devices appear. So a network can be formed regardless of, um, depending on the devices that just join the network. You can have a communication network being formed, and it's what it has also what we call self-healing, in a sense that if a node is removed from the network, the remaining network will look to establish an alternative route of communication. So those are the two characteristics: self-forming as well as self-healing. Okay, the application of Zigbee, of course, it's applied in wireless environmental sensors in terms of temperature, pressure, sound, and luminous intensity. So this application is this technology is widely applied in that regard. Um, in medical devices such as glucose meters, heart monitors, and so forth. These other areas where this technology is applied because um, of its characteristics. Okay, then household automation such as in smart homes, security motion detectors, and temperature. So these are the three main application of Zigbee stroke IEEE 802.15.4 technologies. I guess we end here. Next time we meet, we start looking at Wi-Fi and see how also it is applied.
All right. One to Chief.
Thank you so much for your time, and this will be on the portal so that
All right, Chief.
people can access anytime.
All right, Chief.
Thank you.
Thanks a lot.
All right, bye bye. Thank you.